Good morning, children. Children, today we will start with our second type of reaction, which is decomposition reaction. Children, as the name suggests, decomposition, degraded, broken down. Children, in this reaction, the reactants are decomposed or broken down into simpler products. Children, we can say that this is reverse or inverse of combination reaction. Last lecture we discussed about combination reaction in which two reactants combined together give one product. Children, in decomposition reaction, one reactant after decomposition gives number of products, two or more than two. Now children, in combination reaction, simply I told you that A plus B is equal to AB. So I can say for decomposition, AB, a compound decomposed into A plus B. We just broke down this AB compound into two or more products A plus B. Now children, if I am talking about any degradation, decomposition, I have to apply some force, some energy. Here also children, to going with decomposition reaction, I have to apply some extra energy. Now children, I can apply energy in terms of heat, light or electricity. If I am applying energy in terms of heat, this is called thermolytic decomposition. Children, it is called thermolytic decomposition. If I am applying energy in terms of electricity, it is called electrolytic decomposition. And in terms of sunlight, then it is called photolytic decomposition. So children, in decomposition reactions, we are having three subparts. First one, thermolytic decomposition. So children, first of all, we are going with explanation of thermolytic decomposition. Children, here you can see that we are having one activity in which a girl is performing some experiment. In a test tube, she is having ferrous sulphate crystals and she is applying some heat. You can say that do not point the mouth of the boiling tube at your neighbors or yourself. You have to be very careful when you perform some experiment. Now children, what happened? The girl is performing thermolytic decomposition of ferrous sulphate. Now we are going with how they are performing activity. Take about 2 gram ferrous sulphate crystals in a dry boiling point. Note down the color of ferrous sulphate. Children, another name of ferrous sulphate is green vitriol. Color is green. Heat the boiling tube over the flame, a burner or spirit lamp. Observe the color of the crystal after heating. Children, before heating, it was green color. Now we have to see what is the color after heating. Children, you notice that the green color ferrous sulphate crystals has changed. You can also smell the characteristics odor of burning sulfur. Children, here we are having equation which explain about decomposition of ferrous sulphate. Children, ferrous sulphate FeSO4. When we apply heat, it converted into ferric oxide. Be careful. Ferrous and ferric. Children, we already discussed about valencies. Ferrous valency is +2. Ferric valency is +3. Fe with variable valency. Then children, we are having oxides of sulfur, sulfur dioxide and sulfur trioxide. In this reaction, you can observe that a single reactant breaks down to give simpler products. This is decomposition reaction. Ferrous sulphate crystals FeSO4 into 7H2O. Children, this 7H2O is water for crystallization, which is responsible for green color of ferrous sulphate. Now children, what happened? When we apply heat, first of all, it removes this 7H2O, become colorless. When we go with further heating, it converted into brown color ferric oxide, and the gases are there, sulfur dioxide and sulfur trioxide. Children, here note down one thing. The smell of those gases are like rotten egg smell. So these are your, so children, here you are having some observations. Color change, green, colorless, final brown, and smell of rotten egg. Same with calcium carbonate. Children, when we are going with thermolytic decomposition of calcium carbonate, we are getting calcium oxide and carbon dioxide gas. Children, if you remember in last lecture, I told you that another name of calcium oxide is quicklime. Here, if you can see that we are having heat. The arrow is having heat. What it means? This is endothermic reaction. Children, we apply heat. This is one type of endothermic reaction. So, combination reactions are exothermic, decomposition reactions are endothermic. If we are using heat, we apply heat. Children, the same activity we are having for thermolytic decomposition, but here we are going with another compound, lead nitrate. Children, you can clearly see that from the test tube we are having brown color fumes are there. Figure 1.5, you can see that we are having brown color fumes. Do you know these fumes are having nitrogen dioxide? So children, when we are going with thermal decomposition of lead nitrate, they are having emission of brown fumes, which is fumes of nitrogen dioxide. Now the next page we are having this reaction. Clearly it visible. 2PbNO3 twice, when we apply heat, it gives lead oxide and nitrogen dioxide and oxygen. And this nitrogen dioxide is having brown color fumes. Now, children, we are having one more activity which shows electrolytic decomposition. Children, for that, first of all, we have to understand this diagram very nicely. Okay. Now, children, you can see that we are having rubber stopper, cathode and anode. Cathode always attract cation connected to negative terminal of the battery. Anode always attract anion connected to positive terminal of the battery. Here we are having setup of electrolysis of water. Children, here in a beaker we are having water and two electrodes are there, cathode and anode. Children, when we are going with electrolysis of water, we are having evolution of two gases, hydrogen and oxygen. Children, hydrogen gas is collected at cathode and oxygen gas is collected at anode. Now you can see that here the volume of water is differ. Now what happened, children? We are just putting inverted test tube to collect the gas. Obviously the test tube is filled with water. Whatever the gas is evolved, it just displaces the water from the test tube and gas occupies the space. You can see here the cathode is having more gas as compared to anode. This gas is hydrogen, because in water, what is the formula? H2O. 2 hydrogen, 1 oxygen. Children, in water we are having almost double volume of hydrogen as compared to oxygen. So, more water is displaced. or we can say that at cathode double volume of water displaced by hydrogen as compared to oxygen. But children, this is not a confirmation test for releasing gas H2 and O2. Here in activity we are having one test which confirm about release of hydrogen and oxygen gas. Okay, take a plastic mug, drill two holes at the base and fit the rubber stopper in these holes. Insert the carbon electrodes. Children, we are using carbon or we can use iron nails also. Connect the electrode to battery, fill the mug with water. Add few drops of dilute sulfuric acid. Children, here we are adding few drops of dilute sulfuric acid to become more conductivity or to allow a more amount of current to flow. Now switch on the current. You will observe that formation of bubbles are there. The bubbles displace water in the test tube. Is the volume of gas collected the test tube in both the test tube are same? No. Once the test tube are filled with respective gases, remove them carefully and just bring them near a burning candle. What we observe, children? Children, when you are going to allow a burning candle near to the mouth of test tube, listen me very properly. Oxygen is a supporter of combustion. Okay, it always support burning. Your candle flame become more brighter. Your flame become more brighter. What happened with hydrogen? Children, hydrogen is combustible substance. It catch the fire. Oxygen support firing, but hydrogen catch the fire. So what happened with the test tube? The test tube catch the fire and produce a specific sound. A pop sound is produced. So this is a confirmation test for hydrogen and oxygen gas. Now the third one is photolytic decomposition. Children, here in this diagram clearly you can see that we are having exposed of sunlight on silver chloride and silver bromide. Now children, what happened when we expose sunlight to silver chloride and silver bromide? It converted into silver and release chlorine gas. This is decomposition of silver chloride. Children, the same equation is here with silver bromide also. It converted into silver and release bromine gas. Children, the above reactions are used in black and white photography. What form of energy is causing this decomposition? Sunlight, photon. That's why it is called photolytic decomposition. We have seen that the decomposition reactions require energy, either in form of heat, light or electricity for breaking down the reactants. So reaction in which energy is absorbed are known as endothermic reaction. So children, here we are having decomposition reactions, thermolytic, electrolytic and photolytic. So children, in the next lecture we will start with one more type of reaction, which is displacement reaction. Bye children, have a nice day.